Okay, students, let's move along to the correlation and regression exercise where we're going to take a look at the relationship between regression and correlation. Remember that we're looking at a value between -1 and +1, where 0 means no relationship. 1 is a perfect relationship, positive, and -1 is a perfect negative relationship, meaning that as one score goes up, the other score goes down. Now, we're going to look first at a symmetric measure, that measure of correlation that where it doesn't make a difference which variable comes first. We're going to look at math and English, and the relationship between math and English is the same as the relationship between English and math. There's no direction to the measure. But when we go to regression, there is one variable has to be defined as a dependent variable, the other variable has to be defined as an independent variable, and then we have a set of measures that tells us how much of the variance in the dependent variable we've explained by knowing the independent variable. We're going to create a scatter plot, and when you get to the regression, we're going to interpret the slope, intercept, and r squared. Okay, the data set we're going to use for this is our core CORR1, and when you open that data set, you will find three variables there. We're only going to work with two in this exercise. And one thing you have to be aware of is that sometimes these come through as a default of nominal. So you're going to have to double click on the name of the variable, go to measurement type, and change it from nominal to continuous. And after you've done that for both variables, then we can get started. We'll go to the analysis, and in this case we're going to go to regression. But in regression you'll find correlation matrix. And here we're going to select our math and English, and we'll move them into this one box. And remember, it's one box there because we don't define an independent and a dependent variable. It is symmetric. And between these two variables, we have a 0.767 as our correlation. And you'll notice that at the top, there's a math, Pearson's R, degrees of freedom, and P, and they're all blank. And the reason why is because we only need one. But what we will do is also identify Spearman's R. And for our Spearman's R, we get a score, a correlation of 0.823, which is higher than the 0.767 that we got for Pearson. But they're both highly significant. And if we want, we can look at, for the Pearson's R, we can get confidence intervals. And that tells us if we pull a sample of size 50, that this is what we can expect 95% of the time, that we will get a Pearson's R no lower than 0.622 and no higher than 0.862. You'll notice that the degrees of freedom are 48, and that is n, the number of cases, minus 2, the number of variables. That's the way the degrees of freedom are calculated in Pearson's R. And we can go here for a plot where we can look at our correlation, and this line here is kind of a line of what we would estimate if with these two variables. And if there was a point, this is an infinite number of points that make a line, and the distance between our points, these little dots, these are the actual data points, and the line representing our estimated points, that distance is a distance of residuals. And residuals will come up the more and more you study statistics. It's the gap between our expected and observed values. And this is what we would expect based on our prediction, and this is what we observed. So let's go back up here to regression. And this time we're going to pick linear regression. And in our linear regression, we will select as our dependent variable English and as our independent variable math. And what this means is we're using the student's math score to predict their English score. If there's a strong correlation, then that means that we should, by knowing a student's math score, have a pretty good estimate of what their English score will be. And this tells us that we have the same .767 that we found up here for Pearson's. That is our regression R coefficient. And here's our R squared. And this tells us how much we've reduced, how much error we've explained by knowing the independent variable. So we've explained almost 60% of the variance in English by knowing the student's math score. This intercept tells us the value of y when x is 0. So we have this negative 93.81 if we had a 0 math score. This is what we would estimate our English score to be. And for every unit of movement in math, we will have a 3-point movement in English. And this will give us a picture of that. If we carry these numbers out to 0 in both directions, we would expect the regression line to hit a score of negative 97 on English when we got to a 0 on math. So now we're going to move down. We're going to skip this model builder, but we're going to look at assumptions. And the assumptions we will look at is the QQ of residuals and the normality test. And we will that's it. So let's take a look at this. Okay, so this tells us that we do not have a normal distribution. That our distribution of scores will not meet the assumption because this is significantly different than our normal distribution. And that we can see where we deviate from a normal set or a approximately normal set of standardized residuals. That's the difference between our expected and predicted, or predicted and observed values. If we want to know what scores those actually are, we can go back to our descriptives and take a look at the box plot and the histogram. And we will put our two variables here. And you can see on English we have these 4 high scores and one low score. Oh, this is our math. And on our English we have 4 high scores. So those are our scores that skew the distribution. This is low and these high. These high and that low. Okay. So in another class we could talk about how to transform these variables using a log transformation or other different types of transformations. But we're not going to talk about that in this class. Okay, but one other thing that we can do is we can take a look at our scatter plot. We can look at it outside of what we did with the correlation experiments. So let's just see if that looks any different. Okay, so this is basically what it looks like. And these scores line up very well. This is the reason why we set such a high correlational coefficient. Is because these points are so aligned. As students score higher on math, they tend to score higher on English. And as we saw, if we extended this out to 0 on both, we would have negative, I think it was 90. And for every unit of movement on English, we have about a 3-point movement. Every unit of movement on math, we have about a 3-point movement on English. So that should get you started. We've done the correlation, we've done the regression, we've looked at the assumptions, and it's up to you to discuss the output in relationship to the coefficients and assumptions.